Hey guys, just trying to give you guys a little guidance as you get started on the proving the Redshift problem. It can be a little bit tricky. You need to read it really carefully because some of the questions are actually a lot easier than they actually seem. But let's go over some just basic kind of metric system stuff to start off with. So I have skipped down to the questions at the bottom. Do the questions at the top first, go through it, understand the background and everything first, but then the real tricky part gets to be down the bottom. So for the first question, it says that you're going to use 410.17 nanometers for the first one. So that's the wavelength. So the formula that you're going to use here is velocity equals lambda f, where this is the wave speed. That is always going to be the speed of light. That's the good thing with this. So that is the 2.9979 times 10 to the 8th meters per second number that you have there. Lambda, that's a Greek letter, that's the wavelength. Okay, so that just stands for the wavelength, but we need to get that into meters. So that's one of the things that we will be doing. And then F is frequency. Okay, and that is in hertz, which is basically waves per second. Okay, so that's just to give you a little bit of background here. Now, one of the first things that we have to do is we have to take this wavelength number over here and get it into meters because it's in nanometers. So in order to do that, what you have to do is a nano actually means 10 to the minus 9. Okay, so 10 to the minus 9. Hello? So sorry, just got a phone call there. I'm not sure if you heard any of that. So nanometers are 10 to the minus 9. So we need to take that, and we actually need to move the decimal place over 9 spots here. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. Put the decimal point there. So now we have it from nanometers, we have it in meters, okay, which is where we want it, but now it's not in correct scientific notation, so we actually have to go back the other way. Just to get it into correct scientific notation, as you're going to see, there's going to be a lot of scientific notation kind of like this in this problem going forward. So, and it'll be much easier to deal with the numbers. So if we look at this, we basically need, for scientific notation, we need the decimal point to be in between the first 2 digits. Okay, so we need the decimal point to be in between these two. So it's going to end up being 4.1017 times 10 to the, and then we have to count the number of decimal places that we just moved it. So we went 1, 2, 3, 4, 5, 6, 7. So this is going to be a negative 7. So that's meters. So that's how we change that from nanometers into meters. So, and the rest of them will all have the same exact format as far as problems number 2, 3, and 4. So you can just kind of move the decimal place over a couple spots, turn it into meters, and write 10 to the minus 7. Now, as far as I'll do the first one out with you. So going back to the formula up here. So we have 2.9979 times 10 to the 8th meters per second. So this is going into this formula, V equals lambda F. And then, so that equals 4.1017 times 10 to the negative 7th meters, then times frequency. So if we want to get the frequency by itself, because that's what we're solving for here, we got to divide this on both sides. 4.1017 times 10 to the negative 7th divided by 4.1017 times 10 to the negative 7th. So this and this will cancel out, I should say. And over here, you just put this into your calculator and you will get your answer. Frequencies in the visible light spectrum should be 10 to the 14th. So that's, you're looking for some number times 10 to the 14th. I believe this one might be 7.3089. I could be wrong, but I want to say that that's the answer. So that's how you do 1 through 4. And then for questions 5 and then on, it's really not even that hard. You basically just have to like read the question and think about it. And one of the things that I want to, just get in your mind is you probably want to draw yourself a little diagram. So what the situation you're going to have here is you're going to have the Earth over here, and then you're going to have a star over here, and the light from that star is going to be going this way while the star itself is going that way. So it's going to be asking you what you can do about like the distance from here to here and the distance from here to here, and don't overanalyze it. Okay, don't go crazy. It's not as hard as you want to it might seem. And the other formula that you're going to need is the D equals V times T for questions, I think like 5, 6, and on from there. So the formulas really, both of them are very simple formulas, right? These two formulas are very, very simple. It's just a matter of what numbers you plug in there. So just keep that in mind. Say, what numbers do I need to plug in where? So, time, you're looking for seconds, velocity is meters per second, distance is going to be in meters. All right, so hopefully this helps you out. Feel free to work with each other, call each other up, text, whatever, to help each other out. I understand that this is going to be difficult. That's why I'm giving you a couple classes to work on it. So if you have to like stop and walk away from it and then come back to it or whatever, then that's what you need to do, and that's fine. All right, good luck. Stop in my office hours if you need help.